Let's go ahead and continue working on the real number system by looking at our composition notebook. Now, I glued the graphic organizers to page 5 and 6 of our notebook. On page 5, I glued along the edge and left the flap open. On page 6, I have glued along the two edges, and again, the flap is open so that we could take notes inside. Okay, so let's go ahead and get started on page 5, and let's write down some notes. Okay, so on page 5, we're going to begin by defining several words. We have graphic organizer, Frayer model, and foldable. So let's begin with graphic organizer. A graphic organizer is a teaching and learning tool that is used to organize ideas. Some of the examples that are shown there that I have found from the internet is one that's shaped like a star, and in each edge of the star or each point of the star, it's who, what, where, why, when, with the main idea on the inside. You could also have a flower in which the leaves represent perhaps main ideas of a story or of a character. There are charts and tables. All of these are graphic organizers. Next, we have the Frayer model. Now, the Frayer model is used to define vocabulary terms. It is a visual graphic organizer that helps students understand key words and concepts in vocabulary. Okay, so let's look at Frayer model, which is a visual graphic organizer that helps students understand key words and concepts. So we have graphic organizer and the Frayer model. Okay. Now the Frayer model has 4 sections with a vocabulary word in the center. So I'm just going to draw a quick sketch here of a rectangle with an oval in the center. And over here we put the definition on the upper left-hand side. On the upper right, we have important characteristics or important information. Then we have examples on the lower left. And we have non-examples on the lower right. And the vocabulary word goes in the center. The next vocabulary term on page 5 is a foldable. Now, a foldable is a 3D student-made or teacher-made interactive graphic organizer based on a skill. So I'm putting a 3D student-made, with the help of the teacher, of course, interactive graphic organizer. Now, the term foldable is a new term that has been used by Dinah Zike, in which she describes anything that you glue to your interactive notebook and that you open and close, whether it has a shutter fold. Those are called foldables. Making a foldable gives a student a fast, kinesthetic activity that helps them organize and retain information. The students are engaged. They are cutting, they're gluing, they're coloring, they're applying something to their interactive notebook, and so that makes them engaged. This is called a foldable. Here's some example of some foldables. Now, a foldable can be freestanding, like the picture on the left. It does not have to be attached to your notebook, or you can glue it to your notebook. Okay, so we have been looking at our real number system. We did a graphic organizer in which we have the real number system. We defined the vocabulary words in our Freyer model. We did this already. We did the natural numbers, the whole numbers, integers, rational, irrational, and real numbers. Okay. We completed a class activity in which we created 2 foldables for the interactive notebook. There's an example of mine. And here I have them glued on page 5 and 6. The definitions that we looked at, natural numbers, also called counting numbers, begin with a number 1. Whole numbers begin with a number 0. Integers include my positive and negative numbers, or numbers and their opposites. Whole numbers and their opposites. It includes the number 0. At this point, integers do not include fractions nor decimals. Now, my rational numbers include my fractions. Any number that can be a fraction, as a over b. Irrational numbers are my non-repeating, non-terminating decimals. And all of these subsets combined together form the real number system. I just wanted to emphasize that irrational numbers is a number that cannot be written as a fraction of 2 integers. An example of an irrational number would be pi. Irrational numbers are decimals that are non-terminating and non-repeating. As you go through your notes and you feel you need more examples, feel free to add more examples to the Freyer model. You even have space in beside the flap where I wrote down some more examples. On page 5 in our notebook, let's continue with some more vocabulary terms that are not here. Let's look at positive and negative numbers as they relate to a number line. So here's my number line. Now remember that 0 is neither positive nor negative. So on the right, I have my positive numbers, and on the left, I have my negative numbers. So positive numbers are to the right of 0, and negative are to the left of 0. We have a number line. We also have odd and even numbers. Odd and even numbers. So let's look at those definitions. So remember that I like to use the dictionary, the math dictionary. You can also look up vocabulary terms online. Odd number, a number that cannot be divided exactly by 2. Odd number. A number that cannot be divided exactly by 2. While an even number can be divided exactly by 2. Do we need to even look that one up? Even number, a number that is divisible by 2. Okay. So let's see what I wrote here. I wrote an odd number is a number that cannot be divided exactly by 2, while an even number is a number that is divisible by 2. Okay, the last term I want us to write down is set. A set is a collection or group of numbers. A set is a collection or group of numbers. For example, whole numbers is a set. Whole numbers is the set of numbers that begins with 0 plus the counting number. So each one of these is a set. It is a group. A subset is a part of another set. A set that is a part of another set. So even numbers would be a subset of the whole numbers. Okay, now that we have finished this unit, let's go ahead and go to the back of our notebook and let's go ahead and complete a prompt. So here's my composition notebook. We're going to turn it upside down. Now you're going to be either on page 2 or even on page 3 by now. We have already done a series of prompts, and now we're here. So let's go ahead and begin with today's date, the date that you're working on this. And we're going to go ahead and answer this question. Remember, our standards say that we need to practice oral and written communication. So what is the difference between a natural number and a whole number? So instead of copying the question, I'm going to copy and have that begin my sentence. So I'm going to say the difference between a natural number whoops, almost ran out of room there. So the difference between a natural number and a whole number is. Okay, so these are the type of questions that you might find on the test, in which you have to describe and explain. So let's look at the difference. Now remember that a natural number begins with 1. A natural number starts with 1, 2, 3. Whole numbers starts with 0, 1, 2, 3. So everything is the same except for the fact that whole numbers includes the number 0. So we need to write that as a sentence. The difference between a natural number and a whole number is that the set, notice I'm using the word set because this is a collection of numbers, is that the set of natural numbers does not include 0. Or if you want to say it the other way, that the set of whole numbers includes the number 0, while the set of natural numbers does not include the number 0. And that's it, one quick simple sentence. Remember, if you need to pause the video at any time to complete your prompt, feel free to stop the video. Let's go ahead and continue and practice a few problems in the back of our notebook. We're already here in the back. We just did this prompt in which we wrote down one sentence or two in which we explained the difference between a natural number and a whole number. So right here where we cut this indentation right here, let's go ahead and go to page 12, which are our notes and our extra examples. So let's practice a little bit. And let's practice identifying some numbers. The way they have the -5 in the homework is they want me to identify all the sets that which the -5 belongs to. Now remember our graphic organizer. Let's look at that real fast. We are looking at page 5. And remember that natural numbers is a subset of whole numbers, which is a subset of integers, which is a subset of the rationals, real numbers. So all of these are related. Notice the size of the rectangles. So let's look for -5. Now I know that -5 is an integer. It is an integer, it is a rational number, and it is also a real number. So notice that I'm listing all the sets above it. So -5 is an integer, it is rational, and it is a real number system. Now, real number system is not a choice there, but I'm going to go ahead and write that down. Now, you ask, why is -5 a fraction? A rational number is a number that can be written as a fraction a over b. But remember that I can write this as -5 over 1. -5 over 1. Okay, so -5 is an integer, a rational, and a real number. Let's look at 3/4. Now 3/4 is a rational number. It is a fraction. So looking at my chart over here, it's going to fall up here under rationals. So it is a rational real number. It is a rational real number. So hopefully you kind of get the idea here. So 3/4 is a rational number. It is written as a fraction. And of course, it is a real number. So the next term to look at is the square root of 36. Now be careful with the square root of 36 because it can be simplified as 6. Now if we look at our chart, remember that 6 is a natural number, whole number, integer, rational, real. So I'm going to write these all down. So the square root of 36, which is 6, is a natural number. It is also a whole number. It is also an integer. It is rational, real number. So that was 1, 2, 3, 4, 5. Let's double check our categories. 1, 2, 3, 4, 5. Okay. The next one on the list is 5.603, and then there's a bar across the 03, believe. So this is 5 and, remember when you read this, the decimal point is your and, so it's 5 and 603 thousandths. 603 thousandths. So let's look. This is a repeating bar. That tells me this is 5.6030303, and so on. It is a repeating decimal. Well, let's go to our notes over here and let's see where that is. So I come over here and I remember that a rational number is a repeating decimal. A rational number is a repeating decimal. So make sure you have that if you want to include this as one of the examples. So we have rational number. It is a repeating decimal. Let's put that in parentheses. Which makes it a rational real number. Okay. The next number we're going to look at is -1/2. Now, it doesn't matter whether it is positive or negative, it is going to be a rational real number. It is a rational real number. Okay. The negative square root of 81. Again, the square root of 81 is 9, and the negative in the front makes it a negative 9. So my negative numbers are my integers, rational, real numbers. And remember, in order to make it a rational number, all I need to do is put it over 1. The next number is 0. Now 0 starts with whole numbers. So it is a whole number. It is an integer. It is rational, real number. .6. Now remember, when I read this correctly, this is 5 and 6/10. 5 and 6/10. So it is a rational number because all rationals include fractions. If I wanted to write it as a fraction, then I would write it as 6/10. So it is a rational real number. The next one is pi. Now remember that pi is approximately 3.14. Now it is not exactly 3.14 because it keeps on going and keeps on going. So notice how I put the little wavy signs because it is not equal to 3.14, it's close. So 3.14 is an irrational real number. What makes it irrational, it is that it is a non-repeating, non-terminating decimal. We didn't have to write that down, but I'm studying, so we're just going over our notes. Non-repeating, non-terminating decimal. Now be careful because it doesn't look like it's non-repeating because we normally just put 3.14. But actually, it keeps on going and keeps on going and keeps on going and keeps on going. It never repeats and it never stops. The last one is 7%. Just kind of threw that in there for fun. Remember that 7% is a rational number. If I were to drop the percent sign, then it is just 7. If I convert it to a decimal, it is 0.07. No. So 7% is 0.07 or 7/100 or 7/100. There we go. That's better. And so it is a rational number. Okay, so let me say that correctly again. 7%, if I were to convert it to a decimal, I would move my decimal point over 2 times to the left, so it is 7/100. Or as a fraction, it would be 7/100. So it is a rational real number. Rational real number. Okay. So there we go. So on page 12, in the back of our notebook, we went ahead and did some extra practice problems. Now remember that the back of our notebook is not for homework. We're not going to do all our homework and all our practice, but occasionally we will do some practice problems just so that they will be in our notes. Okay. Okay, so let's go ahead and finish up with our reflection for today. We're going to go back to page 3 or 4, depending on where you're at. Remember, this is the one time that all of you will be on different page numbers. So you're probably on page 3 by now, or maybe even 4, depending on how big you write. So go ahead and skip a line from your last prompt. We're going to put today's date. So let's see what we did today. So earlier, right before the video, we worked on 2 foldables. We did a foldable for the graphic organizer And then we did a foldable for the Frayer model, the vocabulary using Frayer model. And then we opened up one of the flaps and we continued with a few more definitions. So, also include a reflection. Is this the first time that you've seen the Frayer model? What do you feel about that? So the Frayer model is extremely popular in all the classes. The only difference is that they use one giant Frayer model, one vocabulary word per sheet. They don't make little ones. They have a large Frayer model. And so imagine these on the wall of your room, and it's known as a word wall. Okay. So write me a sentence or two on on that reflection. So perhaps you want to talk about the Frayer model or the fact that we created a foldable. Was this the first time you've done a foldable in your composition notebook? Yes, it was a little bit of work. But let's talk about that. Why would we do a Frayer model? Why not just write vocabulary words like we did on a sheet of paper? So the object of the foldable is to make it interactive, to engage the students, have them something to color, to cut, to glue. And when you're walking around the class, you know that everybody's engaged because they're all involved filling in the blanks of the Frayer model or the graphic organizer. It just makes it a little bit more interesting, right? We're trying to get the students' attention so that they pay attention to the vocabulary words. Okay, so in summary, go ahead and write what we did today, including the foldables. So we created 2 foldables for the real number system. We defined some vocabulary words. We used the Frayer model. To define vocabulary words. What else did we do? And we did some practice. And we practiced the real number system. We practiced identifying, is that it with a Y? Identifying numbers in the real number system. That was on page 12. In the real number system. I think I liked. Hey, let's go crazy. I enjoyed. So tell me something about what we did today. Was this your first time using a foldable, creating a foldable? What is the objective behind the foldable? That's very important. Why take all the time? What did you feel about the Frayer model? Again, is this the first time that you've used the Frayer model, and which is very popular in all our classrooms? So go ahead and finish up. Continue finishing your prompts. I hope you enjoyed today's video, and I'll talk to you again later.